It's starting now.
The broadcast is now starting. All attendees are in listen-only mode.
Good morning. This is Steve Cantrell with the last December session for DBA Fundamentals. Today's session is going to be very large databases, lessons learned, given by Bob Pusateri. We're really looking forward to this one, especially at our company, and we have some very large databases that are growing like crazy, and it's becoming more and more of a challenge to deal with them. I've got a few other things to talk about. First, we always have to give our thanks to our sponsor, SentryOne, formerly SQL Sentry. They help us with our giveaways and other things that help support our chapter. Speaking of a giveaway, we will be giving away for this quarter a $750 Amazon gift card that will be drawn from everybody that has attended sessions since September. Every person gets one entry per session. We'll go in and kind of clean out any duplicates because some people think they're going to get a little advantage by signing on with multiple sign-ons, but that's not going to happen. Anyway, everybody gets one attempt per session, and we'll draw that, and we'll have that in the next couple of days. Anyway, SentryOne is a fantastic site to go to for freebies. Of course, they sell stuff too. They're in business, but you can get a lot of free ebooks. We're always talking about Plan Explorer, and they give away their professional version now. If you have ever looked at execution plans, you ought to give this a try and see how you like it. It's fantastic. Anyway, PASS has a lot of different virtual chapters, and if you go to sqlpass.org/VC, you can sign up, and this is for the people that get to us through YouTube. You can attend live sessions and get free giveaways, and at the same time you can ask all the questions in the world that you want. And even if the speakers don't have time during the sessions, they'll blog about it, and they'll give you specific answers to specific problems, not necessarily online, but they try to look at questions and give answers that will help more people, but they will answer your questions afterwards. So you really need to sign up. There's tons of different virtual chapters as well as local chapters on just about any topic and most of the major languages. Here's an example of some of our meetings coming up. Obviously this one, when he had this one last night, that recording will be up pretty soon. In December, we'll be doing one on Windows failover clustering by Edmund Sarmiento, performance tuning methodology as Kevin Klein sees it. Then we have a lot of SQL skills sessions coming up in January, February, and March, and April. So you need to go check those out. Here's some selected sessions coming up the rest of the month. HA&DR is doing one on transactional replication, a deep dive. Practically every site out there still uses transactional replication, and it's very useful in certain situations. Saturday night SQL coming up this Saturday is having Indexing Fundamentals by Kathy Kellenberger. She's a very good speaker. She's with the Women in Technology chapter. You need to check out their sessions and definitely go to these. We record all of our sessions and we post them on our YouTube site, and you can also get the scripts and slides if you need them from our meeting archive site. Okay. Today, I'm going to go ahead and introduce Bob. Bob is a Microsoft Certified Master. He's been working with SQL Server for over 9 years. He's currently a database administrator. Now, his bio said Northwestern University in Chicago, where he maintains huge databases, but he just told me a few minutes ago that he's at a new company and their databases are not quite the size that he was dealing with in the past, but he's got a huge amount of experience with very large databases, and he's getting ready to do a presentation on that. Let me swap over to Bob. Make you the presenter.
All right, I think that's being broadcast now.
Yes, looks like it.
All right, excellent. Well, thank you very much, Steve, for the introduction. Welcome to VLDB's Lessons Learned. As Steve said, I'm Bob Pusateri. I am now a Senior Database Administrator at Insono, which is a managed services company. Have offices in Chicago, and that's where I work out of. By way of a very brief introduction about the rest of myself, yes, I'm a Microsoft Certified Master. I'm a friend of Redgate. I blog on SQL Server and related topics at bobpusateri.com. You can find me on Twitter at SQLBob, and I'm also a co-chapter leader of the Downtown Chicago SQL Server User Group, which is another past chapter. So we're talking about very large databases today, and one of the points I'd like to make at the very beginning is what is very large? Some people may see 500 gigabyte databases as becoming rather large. Others may say, no, it's a terabyte, and still others may say, you know, well, I got 5 terabytes or more. It's very relative within an organization as to what's considered a very large database. Speaking of other things that are very large, this is Oliver. He's my very large orange kitty. He weighs in at about 18 pounds, and I'm going to guess that most of that is not muscle. He likes to eat, and he likes to chew on things, including people, unfortunately. So if you were to actually, as a brief aside, go search the internet for cat bites suck, you could find a nice blog post of mine on how he decided to chew on my wife a couple years ago, and things turned out very, very badly. Going back to databases, so what's a very large database? My personal favorite definition of a very large database is larger than an Excel spreadsheet can hold. Which I know might get some laughs, but in reality, a very large database is probably anything that's large enough that your standard DBA tasks now need to change. As soon as your environment is large enough where your standard rules no longer apply, well, you probably have a very large database. So why are we worrying about this anyway? Why do we care about this anyway? Obviously, we have a large number of attendees here today to learn about very large databases, and for very good reason. As DBAs, generally the amount of data we have is going to be constantly growing. Hopefully all your databases in your environment are getting larger. If the size of your environment is shrinking, that may be a good sign to start getting your resume ready and preparing to move elsewhere. VLDB skills are very generally in demand. The more job postings I see lately will mention VLDB or very large databases, so clearly the demand is there. And so this presentation is going to be a collection of not best practices, but good ideas that I've gathered over 5.5 years of working with very large databases. In a previous position I had, I was dealing with SQL Server databases of up to 60 terabytes in size. That's per database, not the entire server. So we had a lot of techniques we had to employ to keep things manageable and working well for all of our users. Every system is different. Every system has different constraints. Different environments have different requirements. But what we'll talk through today are things that I found worked well for me in the environments that I've been exposed to. So first of all, let's talk about the instance layout. One of the first VLDB environments I ever walked into was just that. It was a really large single database, and that was the only user database on that server. There was a whole bunch of systems that fit into that database, but it was one database. And to make things even more interesting, the production or the development and the test environments and the production environment were all in that database. They were just in different schemas. Needless to say, that didn't really work out very well. So hopefully you'll find a very large database environment with multiple databases segregated by the applications or the use cases. It can be more work to maintain multiple databases, but you get a lot more flexibility when you start doing that. Databases are, by definition, in SQL Server units of consistency. We have one transaction log per database. Everything in the database is transactionally consistent against that log. And when you start having multiple applications which have nothing to do with each other than the fact that they're referencing the same database, you're now essentially enforcing consistency between systems that may not need to be consistent at all. This can lead to complications because other things are per database level as well, right? Backups and restores are at the database level. You can back up, you can restore the entire database. There's no native way to restore individual objects within a database. You'd have to look to third-party tools to be able to do that in SQL Server, and a lot of those third-party tools seem to have been abandoned in the past few years from what I've noticed. Similarly, security is at the database level for many things. There's lots of different permissions: create table, show plan, view database state, things like that. These are all database level permissions. And then there's a lot of configuration settings that exist at the database level as well, right? Your recovery model, whether or not you're using checksums to detect corruption within pages. Plenty of different settings are configurations that apply to the entire database. Now, backups, this is where VLDBs start to show that they're just a little different, because as your databases start getting larger, well, your backups get larger, which means they're also going to get slower. It takes more time to copy more data to a backup. Fortunately, there's a bunch of things you can do here to help. Most people don't realize that backups are, in fact, every bit as tunable as a query. The methods you'd use are a little different, but you can see rather dramatic results by performing different things on backups. So first of all, timing. Let's talk about timing. The time your backups run can very heavily affect their performance. If you are backing up a database during a time period when there's lots of read-write or lots of write activity on that database, lots of changes going on, if you have users updating or inserting or deleting rows, if you have maintenance tasks that are working, perhaps reorganizing or rebuilding indexes, whatnot. If you're backing up a database while these changes are going on, your backup's going to take significantly longer. Part of the backup process involves copying the transaction log, and if your transaction log is seeing lots of changes, you have lots more that you have to add to your backup. So I found that investigating what's going on when backups run can greatly improve their timing, or the amount of time they take to run. For example, in my last environment, when I started, backups were taking over 24 hours, and that was because backups were running at the exact same time as system maintenance tasks. Changing the backup times and actually having backups run during the day when users are querying instead of at night when maintenance was running cut the time from 24 hours to about 8 hours, simply by altering the time that backups were running. So timing can do a lot for you without having to do much more than change a schedule. After timing, probably the next easiest thing you can do is investigate use of backup compression. Now, when backup compression came out in SQL Server 2008, I know it was initially seen as something that was suspect by many, but it's been proven to be extremely reliable, and at this point, if you're not using backup compression, I sincerely hope it's only because your server does not support it. You can cut the time backups take to run significantly just by applying backup compression to your native backups. All right, after backup compression, instant file initialization. Now this is going to help your restores more than your backups, but essentially when you restore a database, the first thing SQL Server has to do is create all of the database files that existed previously so that we can copy the data from the backup into those files. With instant file initialization, or IFI as it's often known, instead of having to create a data file and then zero out that file, where SQL Server will literally create a file and then write over the entire files with zeros, you can skip that, but only for data files, not for transaction log files. But making sure that your server has appropriate permissions to utilize instant file initialization can greatly cut the time of your restores. Multiple backup files. as many of you may know, but some probably don't, when you back up a database using SQL Server native backup, by default this backup will be written out to one file. However, you can write a backup out to multiple files, up to 64 of them in fact. When you back up a database across more files, the backup process will automatically assign more resources to the process. So essentially you'll be able to have more memory and more CPU available for a backup when you're backing up across multiple files. The downside of backing up across multiple files is now you need all of those files to be able to restore. So if you were to back up across 6 files instead of 1, you'd need all 6 files to be able to successfully restore that database. However, when you only back up to 1 file, you still need all of the files to successfully restore the database. Not much difference there. And then finally, once you've done all these other things, there's further buttons you can push to make your backups and restores go faster, and these come in the variables known as buffer count and max transfer size. Adjusting these variables can easily double or triple the speed of your backup processes. And we're not going to go into depth with these because there can be an entire session of its own on backup tuning. But as a brief introduction, these are values you may want to look at changing to increase the speed of your backups. So we've spent a bunch of time and we've tuned our backups and we've gotten them performing incredibly well relative to how they were before. And then our storage administrator comes along and says, you know, you can do these backups and you got them to run in a quarter of their previous time, and that's awesome, but I can just take a snapshot, right? And that snapshot may only take a few seconds. Generally, storage snapshots are instantaneous. They can be very useful for a lot of things, especially if you need to present a copy of data elsewhere. However, when it comes down to it, storage snapshots are still not a backup. They're a snapshot and they're great for a lot of things, but they are not a way to back up data. To give a brief example of how storage snapshots work, if we have this box here which represents our database, we have a very simple database, so we'll just have a single data file, an MDF, and our transaction log, LDF. If we were to create a snapshot of that database, the storage system would then go ahead and essentially create snapshot files which contain the state of those files at a specific time, or contain nothing depending on how snapshots are architected, and then changes will be written out later. Either way, you end up with a copy that you can reference, which is a pseudo copy of the data. However, it's still not a backup. It resides on the primary storage system, on your SAN, on your whatever you have. And one of the cardinal rules I think of backups are it's not a backup until it's on separate storage. You need to get that data off of your primary storage and onto somewhere else, onto another storage system, ideally onto tape, maybe in the cloud, depending on what your organization's requirements are. But once you get it off your primary storage system to where if that SAN, if that data center blows up, you can restore from somewhere else, at that point it becomes a backup. And this can become very apparent when you start looking at I/O errors you may encounter in your environment. For I/O errors in SQL Server, there's what I refer to as the big 3 of I/O errors. These are numbers you'll want to know when you're dealing with I/O. First is error 823. Error 823 is an operating system level error. So SQL Server says to Windows, hey Windows, fetch me this page from disk. And Windows will go, no. If Windows can't get the data for whatever the needs are, SQL Server will retry 4 times. If after 4 times Windows still can't get that data for SQL Server will throw up error 823. 823 is a high severity error which will actually kill the entire connection. It will return 823, and then you'll know right away because your connection will die. That's 823. 824 is a little different. Error 824 is where SQL Server says, hey Windows, get me this page, and Windows says, here you go, and then SQL Server itself determines that the data is corrupt. So maybe something's wrong with disk or with something in storage. Whatever the case is, the data delivered to SQL Server is corrupt. Much like error 823, SQL Server, if it determines the data is corrupt, it will retry to get that data 4 times. If it still cannot succeed, it will throw error 824, and 824 will once again kill the connection. So those are 823 and 824. Now, then comes error 825. An error 825, unfortunately, is not an error. It's actually a warning, and this is where a lot of people don't realize that. So 825, what happens there is the first step is an 823 or an 824 error occurred. So either the operating system or SQL Server determined the data is unusable. But on one of those 4 retries, it actually succeeded. So it failed the first or the second time, and maybe it succeeded on the third. At that point, SQL Server says, okay, we got the data. This is a successful operation. However, it did fail the first time or up to the first 3 times, at which point it will issue warning 825. So 825 is written out to the SQL Server error log, and hopefully if you're checking the error log, you'd notice that. But it's not going to interrupt your application or kill your connection or do anything like that. So one of the easiest ways to start noticing error 825 is to create an alert in SQL Server Agent. And you can find how to do these. You can search the internet for that and find a bunch of people giving examples and scripts of how to do that. But essentially you can set up SQL Server Agent to say, hey, watch for 825, fire off an email to myself or the DBA team or whoever if this gets raised. 825 is often known as the canary in the coal mine. Usually when you start seeing 825, it's a sign of something's going to go wrong in the not terribly distant future. Personally, I was seeing in one of my environments 825 errors for a period of a couple of months. And we had raised this with the storage team, and they kept on coming back saying, oh, the sand's all good, all the lights are green, we're fine, nothing to worry about. And then came the weekend of my wedding anniversary, and my wife and I were out of town, and that's when the entire storage system decided to go down in flames. So I spent most of that weekend on the phone and on my laptop doing restores instead. But what ended up happening after we had the post-mortem is it turns out that the SAN was seeing all kinds of errors and nobody was actually looking for them, and the alerting system was disabled. So all the lights were still green. Not a good situation. So watch for those 825 errors. That may be the only warnings you get. Hopefully, before you get to the point where you're seeing 825 errors, though, you'd notice issues with integrity checks, which is our next topic. So integrity checks, unfortunately, as your databases are getting larger, much like with backups, integrity checks are going to become slower as well. The more data we have to check, the longer it's going to take to check. Now, one of the more common solutions to integrity checks on very large databases is, well, we don't need to run the integrity check on our primary machine, we'll run it on another machine. We'll run it on a replica, or maybe we'll take a backup and we'll restore it elsewhere and run the check there. These are good solutions, but they're partial solutions. You'll still want to check for consistency on your primary machine because you need to test the I/O subsystem of your primary server. If you're taking a backup and moving a backup to another machine and then running an integrity check on it, that's a great way to prove the backup works, but you're not really proving that everything's working in the storage system of the primary machine that you took the backup from. So what I would tend to do in my environments were on my primary server, I would run a checkDB, but I'd run it with physical only. So this is only going to do physical consistency checks. This is going to check and make sure all the pages in the database can be read, they're valid, they're not corrupt, they pass checksum tests. However, we're not going and performing logical tests. We're not making sure that there's a row in every index for every non-clustered index for a clustered index. There's a bunch of logical checks that also go on. We can cut those out by using with physical only. That's what I would do on my primary server, whereas if I had a replica server somewhere else, I'd probably run a full checkDB where it checks absolutely everything. If your databases are getting really large to the point where even the physical only checks are starting to take too long and affect users, there's another option you can throw on called no index, where checkDB will only check clustered and heaps. That will not check non-clustered indexes. The idea being if you suffer corruption in a non-clustered index, well, you can usually fairly quickly alleviate that problem, at least on a temporary basis, by dropping and rebuilding that non-clustered index. But you didn't actually lose any data. Something to keep in mind. Now, index maintenance, since we've talked about integrity checks and backups, now index maintenance, the third of the big three. Surprise, index maintenance will also take longer. My guides for index maintenance are before you start maintaining everything in a very large database like you might a smaller one where issues are quickly resolved and checks complete quickly and rebuilds complete quickly, is determine what your true threshold for fragmentation is. If you have your data segregated or partitioned or however you do it, where you have less frequently accessed data in a different area, maybe in a different table or a different partition of a table, different file group, different storage, however, you'll probably find that that data that's less frequently accessed can definitely tolerate higher levels of fragmentation. Maybe the expectations for running a query on 10 years old finance data aren't the same as what happens yesterday in your environment. And if that's the case, then I would adjust your fragmentation thresholds accordingly. I'd also work on developing a schedule for maintenance jobs, but it may not need to be as regular. In a production environment, in a sales environment where data is changing constantly and being read constantly, daily or weekly maintenance may be normal, but in a larger environment where you have archived data going back many years, you may not need to run that maintenance quite as often. Something to investigate, and that's something that needs to be worked out not only between the operations people but the business people as well. And then finally, for larger databases, instead of blindly running index maintenance jobs, doing rebuilds or reorganize, I would definitely have switched to jobs that will test for fragmentation before actually running those tasks. Now there's all kinds of scripts out there that can do this for you. They will run usually on a regular basis, maybe weekly, maybe monthly, go through all the tables, determine the table's level of fragmentation, and then decide, okay, these are the tables that need to be defragmented, rebuilt. First, let's go through those indexes, and then we can go work on the others later. More or less it'll build a priority queue and run through there, and I definitely recommend this, especially for larger tables. You just don't want to go rebuilding a multi-terabyte index because it's the week where you think you're supposed to. If not much has changed, if your fragmentation hasn't gone up enough, it may not be worth it. Now we'll talk about file groups. As you approach very large databases, you should probably have multiple file groups already, but more than one file group is definitely a great idea. You can give yourself and your environment a lot of flexibility by deploying multiple file groups. You can tier your data by performance when you have multiple file groups. You can have file groups that are on slower disk, and as I said, older or less frequently accessed data can reside on a slower disk. Maybe be cheaper as well. You don't have to worry about having super expensive fast disk for data that someone might look at once a year. Backup and restore performance can also go up by using multiple file groups, simply because when you're using multiple file groups, you need to have more files. You need at least one file per file group. And when you're backing up and restoring a database, again, SQL Server will assign resources to the backup and restore processes. One of the criteria it uses is how many files are involved. So if you have a database with more files, it will by default get more resources for its backup process than a database with less. Partial restores are also available when you're using multiple file groups, and we'll talk about those in a little bit, but essentially if you don't need to bring your entire database online at once, partial restores will make that happen for you, and they can make your uptime recovering from a disaster be significantly lower by bringing up the data that you need right now as quickly as possible, and then working on data that would not be needed as quickly at a later time. And then finally, you also have the option for read-only file groups, and these they don't serve as much of a purpose as they used to. So back in the day, before SQL Server 2008, when data compression as we currently know it came about, in SQL 2005, you could utilize, instead of SQL Server compression, you could utilize NTFS compression and actually have the compression occur on the file system. This was a big pain, but it worked. But one of the requirements was the data could not change, so you actually had to have your data in a read-only file group. So you basically put the data you wanted in a file group that was read-only. You'd then apply NTFS compression at the file system level to compress that data, and SQL Server would handle it from there. Probably not as useful today as it used to be, but the option still remains. When you have multiple file groups, one of the issues you'll run into is you'll probably need to enforce correct file group usage. So if you had a database that, would by default just have a primary file group and now you added another one or many file groups, you'll want to make sure people are putting or creating objects in the correct file group. Unfortunately, SQL Server has no security settings behind file groups. There's no way to say, these users cannot create objects in this file group. So if you have users creating objects, you may need to make sure they're creating data or creating their objects in the correct file group. And there's a couple different ways you can do this. I've seen creative usage of triggers. I've seen event notifications used to do this. I've seen resizing a file group, making it really small, maybe just like 50 megabytes, and the idea being, yes, someone can create a table in there, but as soon as they start copying any decent amount of data in there, they're going to run the file group out of space, and then they'll start asking questions. But you'll need to find a way to make sure that the correct file groups are being used. Because just because you make a file group the default file group, yes, by default, all new objects will go to that file group. However, if someone's copying, pasting a script and it says, create object on primary, then it's going to go in the primary file group, and there's nothing you can do about it. Similarly, when you start re-architecting your file groups, this is of course much easier when you're creating a new system, but if you have an existing system, you may have the problem of needing to move data between file groups. This can vary in difficulty depending on the contents of your database. So for example, if you have clustered or non-clustered indexes or heaps that you're dealing with, these are pretty easy to move. You can rebuild a clustered or a non-clustered index in a new file group. You can do that online, and people may or may not be affected by that. Heaps are a little more work simply because you cannot rebuild a heap. You'd have to take and build a clustered index on a new file group and then drop the clustered index later, and you'd have a heap again in a new location. Those are rather simple. Where things start to get a little more complicated is when you're dealing with lob data, with large object data. At this point, this is not easy. There are ways I've seen to move large object data between file groups with the database online. If you're going to take a downtime, this is much simpler. You can just copy the data over, or copy the files over to a new location. But if you're going to keep the database online, then you're probably going to have to do something like create a new table on a new file group, copy the data to that new table, copy all your indexes, permissions, triggers, and everything else you had to those new tables, and then play swappy with the names, switch the names around, and then drop the old table. And while the whole time you're doing all this stuff, you got to make sure that nobody else is updating anything. This can get to be a problem really quick. So this is something you'd want to plan out well in advance. That's file groups. Moving up the chain once more to storage and talking about actual drive letters and mount points. There is a common belief out there that more drives can mean better performance. Not necessarily. Adding drives and adding storage to systems, especially enterprise quality storage, not cheap. And there's usually simpler ways to fix most performance issues. So I would definitely recommend investigating other problems before you go and say, we need to solve this problem by adding storage. Now, of course, if you're running out of storage and that's the main issue is you don't have enough space for your data anymore, then you have to add storage. But if you're saying our performance is bad, we're going to fix this by adding some more disks, you can probably achieve a more dramatic performance increase by using other tuning methods first, would be my advice on that. Higher availability, and I like the term higher availability as opposed to high availability because you can still have failures in a high availability system, just hopefully you've decreased the chances of that occurring. As I just got done saying, disk is not cheap, and as you have larger and larger databases with more and more disk, it's definitely getting more and more expensive as well. Now, if you're using high available solutions such as mirroring or replicas or log shipping, these are great, these are wonderful, but they all duplicate the data, right? In a mirroring setup, you have a principal and a mirror. These machines both have their own separate disks. You have two copies of your data, essentially. Whereas if you're looking at something a little more old school, like a failover cluster instance, now you're dealing with a shared disk. You don't need to buy multiple copies of the disk, at least not in your primary environment. Hopefully you have a disaster recovery environment somewhere else which will require more disk, but you won't need one per node. like you would for mirroring or log shipping or with replicas. The downside with only having one copy in your primary environment is, of course, now you have a single point of failure with your storage. However, hopefully your storage system is robust enough and your backup protocols are robust enough to be able to survive issues should they arise. Talking about restores, and we touched on this briefly before, I said partial restores can definitely be your friend. And I'll actually correct myself, and a lot of people will say partial restore. Officially, according to Books Online, the term is a piecemeal restore. I've been corrected on that one before. But the question you need to ask yourself and your business users are, do you need the entire database restored right away? As I said, if you're using multiple file groups, you can do a piecemeal restore and only restore the primary file group and other file groups as needed. So you can bring this year's accounting data online right away and have that up in 20 minutes, and then we can work on last year's, and that'll take another half hour. But we have, we have 2 years of data up in under an hour, at which point the other 20 years, well, those can wait till tomorrow or tomorrow night or next week, depending on what the situation is. So piecemeal restores allow you this flexibility of bringing some of the data up right away, worrying about the rest of it later when we have more time and more bandwidth and people are back at work after spending all night fixing whatever issue created this problem in the first place. Partitioning. So as your objects are getting larger in your databases, partitioning may start to sound like a better and better idea. Table partitioning, of course, is where you have a partition key, you have a column that you are splitting the values in your table on, and then you are, depending on that value, writing the data to different partitions within that table. And the real performance increase for partitioning is twofold. When you are querying your data, if your query involves a field for that partition key, you can now know, instead of having to scan an entire table, I only need to scan a particular partition to find all the values that qualify. That can dramatically cut your query times. But also for loading and removing data, partitions allow you to do what's called partition swapping, where you can swap a partition in or out of a table and effectively move that data around. However, you don't have to move the data to do it. All you're literally doing is swapping partition IDs. So to give a very brief example of this, if this is our partition table here, and we have 4 partitions in our table, as you can see, we create 2 more tables with identical column and index structures, and we load the data we want to load. We want to load more data into table A. We're going to start doing that by actually loading the rows using a bulk load process or whatever into table C. And then we're going to swap that partition from table C into table A. So I'm going to run this animation now, and this is my first attempt at animations in PowerPoint, but you'll see here we'll have partition 1 from table A is being removed. It's being moved to table B, and then the partition that we just loaded from table C is swapped out into table A. These are very quick operations at this point. When we're loading the data, we're doing it in a different table, so we wouldn't be affecting users trying to query the table at that point. And you can swap a partition in and out very quickly. That's an advantage of using SQL Server partitioning. Now there's also another option to partitioning that can be rather attractive depending on your environment and depending on also what edition of SQL Server you have. Now, I should mention that it recently, in the past few weeks, was announced that SQL Server 2016 Service Pack 1 had many new features that were added into the Standard Edition, which were previously only available in Enterprise Edition. Table partitioning was one of those features. So if you're using 2016 Service Pack 1, you now have access to partitioning, whereas previously that was an Enterprise Edition only feature. What I used to tell people who were using Standard Edition and needed the query advantages of partitioning but didn't have the money to purchase Enterprise Edition was you can use what's called a partition view instead. And this is still a perfectly valid method even in an Enterprise Edition environment. Essentially what you do is, instead of creating partitions within a table, you actually go and you create multiple tables. And these tables are divided once again on a particular value, on your partition key essentially, And when you create these tables, you create check constraints to enforce the values in that table fall within whatever your partition range is. At that point, you create a view and you simply union all of the tables into the view. So you'd have a, create view, select table 1, union all, select table 2, etc. At which point, when users query the view, the query optimizer will be smart enough to read the check constraints on those tables and realize that if you're searching for a particular value and it's divided by that partition key, then, well, I don't need to scan every table that makes up this view. I only need to scan particular tables. So you could do this, and like I said, you can do this in standard editions of SQL Server, and you will get the query advantages of using partitioning. You will not get the data load advantages that partition swapping brings in, but you'd get the querying advantages at least, and this works in standard edition. So I definitely recommend taking a look at that if you have a very large database that is not in Enterprise Edition or is not SQL Server 2016 Service Pack 1 Standard Edition. So to sum up partitioning, I'd say that partitioning is great for loading data. Like I said, that partition swapping can be extremely quick. That's a metadata operation, so it's going to take, fractions of a second to complete. But if you don't have the ability to use table partitioning, try out partition views. Definitely something you'd want to test beforehand, but you could see great results from that. And partitioning, like I said, is really only good if you're always filtering on your partition key. If you have data if you have to run a query that does not know the value of the partition key, partitioning is not going to work to your advantage. In fact, it may cost you more performance because when you have to merge results together from scanning different partitions, that can actually take more time than just scanning a single partition by itself. So you definitely want to make sure that the majority of your queries, or at least the queries that you really care about performing well, are filtering on that partition key. I used to work with medical data, and we had some large tables with billions and billions of rows, and we actually did not apply partitioning to these tables simply because there was no real good way to partition them. We could partition by date, by the date an event occurred. However, most of our queries, most of our users who were looking for data in a research setting weren't trying to search across a specific date range. They wanted to know, tell me every person who came in with a fractured arm since the beginning of time. Well, that's going to take some time, and you're going to have to scan the entire database or the entire table to find that information. There's no date data associated with that, so we can't filter on a partition. So there were lots of instances like that where partitioning just didn't work. So you really need to make sure that the type of queries and that your environment would benefit from this before rolling out something like partitioning. Next, let's talk about data compression. Now, SQL Server has had data compression since 2008, and you can get some great advantages in performance and save yourself some disk space with data compression as well. So data compression occurs, and I'll have my very simple graph of a database system here. So we have end users connecting to the database. They're writing a query. There is access methods, which are determining what needs to be read, what pages of the database actually need to be read from memory, and if they're not already in memory, we need to bring them in from disk. Now, when you go ahead and you apply data compression occurs in SQL Server within the access methods. So what that means is when we apply compression, essentially the data is compressed both in memory and on disk. This is good for several reasons. Number one, you're saving disk space, but you can also fit more data in memory now in the same amount of memory because it's compressed and it's taking up less space in memory. There's a lot of storage vendors out there that have various storage systems and appliances that will do compression, and those very often can do better compression than SQL Server can. You can achieve more savings on disks, but the one thing they can't do is they can't compress the data in memory on SQL Server. So this is something you definitely want to try out on your own if you're testing a new appliance. Hopefully you get it on a trial basis or something first. See what the difference is, because yes, even if you have an incredibly fast flash storage array, the one thing that's faster than reading from an incredibly fast storage array is not having to read from that storage array because your data is already in memory. And when you're using SQL Server compression, your data is already compressed when it's sitting in memory. One of the downsides of using data compression in SQL Server is that data is never cached in a decompressed state. We need to decompress the data before returning it to our user. That's why the user is on the decompressed side of the line. But there's no caching of decompressed data that occurs. So essentially, every time a user reads a row, even if it reads the same row a million times over, you'd have to then decompress that data a million times over. Data compression, as I just said, it compresses data in both disk and on memory. There's two flavors of data compression in SQL Server. There's row and there's page compression. Row is a simpler, faster form of compression that works in a lot of cases. In some cases, page compression can get you even more savings. It depends on the degree of which values are repeated in your database and within a page. That's something you test out when you're applying compression. Moving on to statistics. Statistics are, of course, very important in a database. SQL Server will use values from statistics to determine a query plan before the query even starts updating. So you'd like to, generally, on a small database especially, you'd like to keep your statistics as up-to-date as possible. However, as your tables start getting larger in SQL Server, even if you have auto-updating statistics enabled, those updates will become less and less frequent. And that's simply because of the formula SQL Server is using to determine when to update statistics. SQL Server keeps track of how many rows are in each object, in each index, and then it will keep track of how many updates have occurred since the last statistics rebuild. Now the formula that it will use and used to use by default was 20% of the rows plus 500 rows had to change to trigger an automatic statistics rebuild. So if you have a table with 1,000 rows, well, that'd be 20% of 1,000, or 200 plus 500. So once you had 700 out of those 1,000 rows change, then you'd have an automatic statistics update occur. That may work fine for smaller tables, but once you start getting up to tables with billions and billions of rows, you start needing millions and millions of updates to trigger an automatic statistics update. And oftentimes you won't see that much churn in tables that large. So you can either run statistics manually more frequently, or there's a trace flag you can apply, and it's trace flag 2371, that will change the threshold for auto statistics recalculation. So I will show you on the next slide a chart of exactly how that changes. But another question to ask is, are running statistics more often really improving your performance? Because if you start having really large tables where the data doesn't change very often, you may not need to run statistics as often to begin with. But again, this varies heavily by environment. So when you enable trace flag 2371, or when you're using SQL Server 2016, because this is the new default behavior in 2016, instead of the default threshold of 20% of the changes, which is represented by the blue line there, you'll see that the threshold now becomes dynamic, and it now follows that red line instead. So as your table starts getting larger and larger, the percentage of rows that need to change becomes smaller and smaller. This will cause more frequent auto updates of statistics, but that may improve your performance for queries by having statistics be refreshed automatically more frequently as opposed to doing it manually yourself. All depends what you're looking for in your environment. Another thing to think about is parallelism. Are you getting all of the CPU that you've paid for? You've bought a box with 32 or 64 cores, and you've paid a bunch of money for SQL Server licensing for all of those cores, and then you go ahead and you deploy queries with scalar UDFs, which just utterly decimate parallelism. It's not even possible. There's a bunch of other SQL Server commands you can use that can affect the SQL Server's ability to parallelize queries, and you can actually see an excellent blog post by Paul White on those topics, or on those lists of functions and what they do, so I would definitely recommend checking those out. But make sure that the queries you're running can, as often as possible, take advantage of all that CPU you've paid for to purchase and to license. Okay, we're getting towards the end here, so we'll talk about security real quick. Your databases are getting larger and you have more and more objects in your very large databases. Definitely want to look into using security roles if you aren't already, simply because you can package up a bunch of permissions in a role and then add users or logins to those roles. This makes life a lot easier when someone needs access, when you have someone new join the team or whatever, and they need security provisioned for them. Rather than having to go out and assign all kinds of ridiculous permissions, you can add them to a role and be done. Definitely can make your life easier. You'll also find that as you have more and more data and perhaps more and more sensitive data in your systems, you may need to keep track of what your users are looking at more frequently. So what I like to tell, the story I like to tell with this is actually the story of this building. So this is the last remaining part of a building. It's actually just outside of Chicago. Western Electric used to have a massive factory west of Chicago in a town called Cicero, and it was called the Hawthorne Works was the name of the factory. And Western Electric made all kinds of things. They made telephones for the Bell system for a long time. They made appliances. They employed thousands of people in their heyday. And it was seen as a great place to work. And because there were so many workers doing so many different tasks, it was also seen as a great place to actually do academic research on the behaviors of workers. So there was a lot of formal academic studies commissioned on how workers work, how can we get people to work better and more efficiently, all kinds of things like that. And one of the effects that was proven scientifically at the Hawthorne Works was actually named for it. It's called the Hawthorne effect. And you may not have ever heard of the Hawthorne effect, but when I tell you what they proved with the Hawthorne effect, I'm guessing you will realize that it's pretty common knowledge, but of course at some point someone had to scientifically prove it. So the Hawthorne effect states that people generally tend to behave differently when they know that they're being watched. Okay, they did a bunch of work and proved that, you know, when workers know they're being watched, they tend to work better, harder, faster. Whereas if they don't think anybody's watching, they may not care as much. Same can be said essentially for security. So if you have a database with all kinds of active security with things denied, people may not, you know, try to do anything, but if you have a more passively secured system, maybe you have users in your environment you can't deny access to. Maybe the big boss wants system administrator access in your database and you really don't trust them, but you're not in a position to say no. This is where passive security can come in and really help. There's a couple methods you can use to passively secure your databases, and this works for databases of any size, but if you're not familiar with SQL Server event notifications, this is essentially you can set up a notification and be notified as soon as someone does something that they shouldn't. Maybe selects from a table or creates a table in the wrong file group. Things like that. You can actually go ahead and create an event notification and have something happen, generally, you know, an email or other notification event go on when something occurs. The second thing you can do is, of course, auditing. You know, depending on your environment, you may already be required to do auditing if you deal with financial data, healthcare data, personally identifiable information, and the like. You may need to know exactly what users are seeing at all times. Hopefully, you have an audit system set up to capture that information for you. Something else to think about when you're thinking about security, you're putting all this effort into auditing your database and what people are looking at in the database. What about the actual Active Directory groups that people are in? If you have an Active Directory group of system administrators and you're watching who's, you know, in the system administrator list, that's great, but if someone goes and adds someone to the Active Directory group, that'd be transparent to your database. You wouldn't know that. Active Directory notifications are something you may have to work outside your team with. If you're not an Active Directory administrator yourself, you may need to go consult with your AD team. But I found more often than not your AD team can do things for you like set up notifications at the AD level. So as soon as membership in a role or a group changes, an AD group that is, they can actually send out an email to, you know, a person or a group and say, hey, someone in this super administrator group just got added to it. Is this what we want? Definitely a good sanity check there. And then finally, the last thing I'll talk about with very large databases is read-only mode. Concurrency is the cause of many issues in a database when you have users reading and writing data at the same time. And if you know for a fact that this data is not changing and will never be changing, well, then read-only mode may be for you. You can place a database in read-only mode and essentially have no more concurrency issues because the only activity people can do is read. Since the database is in read-only at this point, statistics can actually be stored in the database, so they go into tempdb at that point for statistics. And the downside really of read-only mode is it's very disruptive to switch between read-only and read-write mode in a database. You would need to put the database in single user mode, switch it to read-only mode, and then bring it back into multi-user mode so that people can read from it. But it can be done. So with that, that is all I have for very large databases today. Happy to take questions. I see some have queued up here. We can take those, and then if you want to take questions offline, you can also feel free to reach me via email. I'm also on Twitter, and I do have a resource page up on my blog you can check out with links to some of the things I cited. So that's what I got.
Okay, Bob, I'll start from the top. This was back when you were talking about snapshots. User asked, do we need the storage to freeze IO checkpoint in order to create a working snapshot?
Does the storage need to freeze an IO checkpoint to create a working snapshot? That depends on your storage system. I've seen storage systems where that is necessary, and I have seen storage systems where that doesn't matter. They've created other workarounds. So that unfortunately is going to depend on your environment. More often than not, I've seen storage systems that do need an IO freeze for that, but it's usually on the order of seconds.
Okay, this user wants to know about some of the challenges associated with always on availability groups because they're trying to deploy a 1.2 terabyte database. We have MBFs present on 2 drives, E and F, where disk IO is different in reads and writes. And we're facing low query execution. Do you see that question? It's actually they put 3 together. Do you understand what they're trying to ask?
I see them here. I'm going to say that's probably better suited to take offline, so maybe we can address that via email instead of right now, if that's all right with them.
That's probably all right. Then they'll get their answer.
Yeah.
The next question is they just want some general ideas, and I think you've given those general ideas of how a 24/7 shop would go through. That's what the entire presentation was about. I'm assuming at the resources you're going to have this stuff listed out, and plus they can look at the archive and see that again, but do you have anything to add to that?
Part of the biggest challenge of a 24/7 environment is hopefully you have a time in your 24 hours a day where there is an activity lull where you can work on things. I've seen environments where there is no lull, and then they start using other techniques, like maybe we'll divide our users into different groups because maybe it's a 24/7 global shop, but there is still hours a day when everyone in the United States generally is in bed and activity is higher in other regions of the world, in which case they'll actually split up their environment by geographic location and perform maintenance that affects users when that group of users is most likely to be not utilizing the system. There's a bunch of different ways to do it. Those are some of the general ones I've seen, as well as just trying, most of the techniques I think I addressed in the presentation were methods to do this with minimizing downtime where possible.
Okay. There's the next user is talking about database scoped configuration with 2016. Let's see. Do you see? It's that real big question. Okay,
Okay, hang on. I'm looking.
I haven't really worked with that yet, so I don't know.
I actually have not either, so I am not going to be able to answer that question at this time, unfortunately.
Okay. Is there any added value to move a very large database onto Azure?
If you placed higher value in paying more to Microsoft to have it there than having it in your own environment, then perhaps that's probably a case more for your business people. There's also the ability, there's Azure Stretch DB where you can put part of your database in Azure and have part of it on-prem, but now you're paying all kinds of money to have that data up there as well. So that's kind of got to determine where you want your dollars to go and for what reason. If you feel that Azure is bringing you more advantages by putting it there, well, then it may be worth it for your environment, but I'm guessing others would probably say maybe it's not worth it. So
it can get pretty expensive. I'm thinking that archive data might be the only, and utilizing it with stretched databases might be the only way that it would be cost feasible for a lot of people now. I mean, that's going to probably change in the future.
Yeah, I would like to think so.
We're also facing the option of unable to rebuild an index online in standard edition with
a 900 gigabyte database.
Yeah.
You're right, and I don't believe that was added to the newest
I don't think
update
it,
of 2016
I
either.
don't think it was either, because that's one of the big things that people want with Enterprise. So,
Yeah, yeah, I think that's one of the things Microsoft kept with Enterprise. So this is one of those situations where, unfortunately, you have constraints put on you in Standard Edition, and you got to abide by those constraints. And occasionally, a lot of the features that Microsoft kept in Enterprise Edition that it did not put in Standard Edition involve greater uptime. So if you need more uptime, well, Enterprise Edition may be for you, or you may have to take a scheduled downtime to perform maintenance tasks like this.
yeah, they're not going to give away everything. So
Nope.
they're going to keep some things so people, I think as it stands, it's availability groups and things like this that they kept. Okay, how do you define foreign key constraints on partition tables? Partition gives me a headache regarding unique constraints as they're evaluated just at the partition level as far as I recall. What do you do to ensure data consistency between partitions?
Oh, boy.
I've never run into that
I
either.
have not run into this, so I will have to address those questions offline.
Okay, that makes sense.
Yeah.
How quick is a partition swap? Data integrity is preserved, correct?
Correct. Partition swaps are metadata operations, so they're as quick as swapping, one integer for another. Essentially, they can be under a second easily, and data integrity is preserved during that process. So that's part of the allure of partition swapping, is the fact that you can do this atomically.
Okay, what are the disadvantages for purging and removing data?
Probably the biggest disadvantage for purging and removing your data is you don't have that data anymore.
That's one.
Part of the big data movement is clearly that we have more data we've saved. We were able to save due to cheaper storage and whatnot, and now we can do more analysis over greater periods of time because we have more data. So yeah, I've worked in environments where purging data has been encouraged to save space, and more and more often these days I find that the general attitude is let's not delete anything. We don't have to. Let's find a way to save it somewhere, even if it's in an offline environment where we can't access it quickly. We still have it for later when storage becomes cheaper or some new technology come out, and we'll have this data. We can analyze it at a later point.
Okay, the next question is, if you're on flash drives, I understand it's better to keep stats up to date rather than run re-indexing. Is that correct?
I'm going to go again with it depends. Definitely statistics up to date are always going to help you. I think there's still a lot of people out there that are saying, re-indexing. Re-indexing in a flash drive is kind of an interesting proposition, because most things, when you have data on a flash storage, it's generally always going to be fragmented. That's going to be part of it. So if you're using a flash drive to prevent fragmentation, that's not the use for it all. What makes flash drives so appealing, for one of many things at least, is the fact that the searches are so fast through it that even when your data is highly fragmented, you're not going to see performance hit from that. Your flash drive can handle highly fragmented data incredibly easily. That's not an issue for it at all. However, re-indexing can cause issues with SQL Server simply because you'll have, even though the fragmentation doesn't matter to your flash drive, it will matter to SQL Server. You'll have pages with very low, if you had a data page on a highly fragmented table, maybe your data pages are only 10% full. Well, your flash drive doesn't see a problem with this, but now you're wasting all kinds of space storing empty data in pages because your data is fragmented, and re-indexing would help that part. So you can get away with running re-indexing less frequently in SQL Server on a flash drive, so long as you don't mind the fact that you're probably wasting space. At which point you probably want to run the re-indexing anyway. A lot of people will make the argument that you'll wear your flash drives out, you'll issue too many write commands, and it'll go bad. And this was definitely more true 5-10 years ago than it is today, but most of the enterprise flash I've seen today is incredibly robust and can handle years and years of getting pounded with writes. So I'm not sure that's as valid of an argument, at least that facet of it, as it used to be.
This might be an answer for the person earlier that had the 900 gigabyte database on standard. That have to try to balance the cost of an enterprise license against the cost of the flash drives, but those are coming down every day. So the next question is, when you truncate a table, will the stats also drop?
I believe they will. I don't remember off the top of my head for sure, but I'm pretty sure they will because they'll be invalid at that point anyway.
Okay, and this is sort of the same question as earlier. How can SQL Azure be leveraged in the management of very large databases?
Yeah.
Depends on your business case and cost.
Absolutely.
I love this. Monty Python fans, I'm going to read it anyway. What's the airspeed of an unladen swallow?
Oh boy. Well, Greg, that depends if it's an African or European swallow. So.
Nobody's ever asked that. I love that though. But anyway,
there we go.
Thanks a lot. Great presentation. One person earlier, since we've got a minute, wanted to know if your wife was all right because they had read the follow-up on the cat bite story. So
yes, she's fine. She has full use of her finger these days. Got a little scar there because they had to do surgery, but she's good otherwise. And the next most common question we get from that is, do we still have the cat? And the answer is absolutely. He's standing outside my office door looking at me right now, actually.
He wanted to see how you answered that. Okay. Well, we really appreciate it. This was a great presentation. We'll have to have you back sometime. I really like the way you did it. Next week or next month, let's see. Wait, so we've got some more. Okay, there's some more questions here all of a sudden. Okay, hold on.
Okay.
Got a few minutes.
Sure.
Sorry, I didn't roll up the screen. Can a database snapshot do? Well, I don't understand that one. Snapshot do database become more slowly? Does a database snapshot cause the database to perform more slowly?
Does a database snapshot, so if you're using a database snapshot, that's a snapshot within SQL Server, does it cause the database to perform more slowly? The appropriate answer is yes, but the real answer is it may not be that apparent. It will be slower by virtue of you're doing more, but it probably won't be apparent to your users. When you have a database snapshot active on a database, essentially every update you issue on a database, whether it's an insert, an update, or a delete, will actually go ahead and copy pages from the primary data files into the snapshot data file. So you have data moving every time you do that. But that only occurs the first time you do that. So if you update a row, the original version of that row will get written into the snapshot file. But then any subsequent updates to that row won't occur. But you're essentially keeping track of more and you're doing more. So you will see there will be a performance impact, but again, it may not be significant to the point where people would actually notice. Definitely something you'd want to test with before just going ahead and getting crazy deploying database snapshots. Now, the snapshots I talked about were storage level snapshots, so that's on the storage system as opposed to within SQL Server. But essentially your storage system is going to be doing the same thing, just behind the scenes that SQL Server would be doing, or an equivalent operation at least.
Okay, this question, is it safe to add MDF based on VLF count or the size of MDF? I don't quite understand that. Do you see that one down towards the bottom?
Hang on, I'm looking here. I'm scrolling through.
About 8 from the bottom.
About 8 from the bottom. Hang on. I wish it numbered these questions. Is it safe to add MDF based on VLF count or size of MDF? Well, usually when we're talking about VLFs, we're talking about the transaction log, and I'm not sure how adding MDF files or data files would affect the number of VLFs, other than, it would write into the transaction log there's a new file present, but I don't think it would increase the number of VLFs because it's not adding the transaction log at that point. I'm not, unfortunately, I don't understand that question enough to be able to answer it for them.
Okay. Let's see. The rest of the questions have to do with partitioning, and this is not necessarily a petition. If you want to talk a little bit about partitioning, that would be good, but I think you've been doing that all along.
Okay.
Some of these other questions have already been answered. So what I'm going to do is I'm going to send the rest of these questions to you, and you can follow up in a blog. We always offer that, and speakers usually love that because they got new blogging material if they don't finish questions, but we're going to have to close it down right now.
All right.
I really appreciate it. We'll we'll discuss about getting you back sometime in 2017. And thank you. And we'll see you next month with the Windows Failover Clustering session at the first of the year. Thank you, and have Merry Christmas and Happy Holidays. Thank you.
Thank you very much for having me. I appreciate it.
That was very good. I like that. We're gonna definitely have to use some of those things coming up, especially partitioning.